I'm Chris Rachel Oslin with the Austin Post. We're here at ATI interviewing more local startups. Today we are talking to Alafair Biosciences and Dr. Dan Peterson. Can you tell me a little bit about what Alafair does?
What Alafair, the problem that we address is that of postoperative surgical adhesions. Anytime a patient undergoes a surgical procedure, there's a risk of tissue injury, and obviously we want patients to heal from surgery, but sometimes when healing occurs, it can tether together tissues that should slide against one another. So that's the process of adhesion formation. Adhesions can cause a host of problems: infertility, chronic pelvic pain, limb immobility. It goes on and on. There's about $3.5 billion spent in the United States every year for hospitalizations related to adhesion-related disorders, reoperations, prolonged physical therapy, and these sorts of things. So we've identified a material at the University of Texas that is similar to the best product on the market, but has much better handling characteristics for the surgeon in the operating room. So we've licensed that technology from UT.
What did you mean by handling characteristics?
Well, anytime you're, as a surgeon, when you're in the operating room using a material, using a product, you want to be able to, for this type of material, you want it to be able to be placed where you want it, be able to reposition it. Tissues are obviously wet, so you want it to be able to handle a wet environment. And then you want it to stay in place where you put it so that it does what you want it to do. And so the products that are currently on the market generally have some real shortcomings. They're kind of like a Listerine breast strip, if you will. They are. So as soon as they get wet, they turn to paste. You can't put it anywhere. So very difficult to apply. And that's left surgeons kind of wanting a better solution.
Yeah.
And we think we've got a solution that fixes all of those shortcomings.
So it can be used in a wet environment, doesn't turn into paste. What does it actually do in that wet environment? Just seals those tissues together where they're supposed to be?
It actually provides sort of a preventive barrier. It's made from complex, naturally occurring sugar molecules that attract water very strongly. So as they attract water, they repel proteins and cellular debris. And so those are the things that start the scar tissue formation. So what it does is it prevents that initial part of the scar process from happening.
I find things like that really exciting with biosciences because we don't really think about, just how much things have evolved from like Romans using wound staples to what we have now. It's been a really exciting period very recently.
In the last 20 years, very interesting.
What are some of the things that have allowed the evolution of biosciences to just jump forward so much in the last 20 years?
Well, I think, you have to look at, the academic research environment. And, the United States has such great funding for academic research. And the University of Texas is an extremely fertile ground for creative technologies, and the ability to, identify them and license them and then flesh them out is what's really exciting for us right now.
So is your main job actually to come up with these grand ideas, then see if you can figure it out, or do you have graduate students under you that are pitching you ideas constantly?
Well, with this technology, anytime you identify technology and you commercialize it, you really have to focus on what your core competency is. And that means identifying what the product does, what the market for the product is, identifying the regulatory path, getting it through the FDA, which is an enormous hurdle, and then identifying what the sales and distribution opportunities are. So that's really where we're focusing. We have looked at some other technologies that would be complementary to our lead technology, and would like to bring those on and sort of build out our portfolio as we grow.
So how did you first come up with this particular idea?
Well, I honestly didn't come up with this idea.
Well, how did your team come up with it?
So I am a practicing neurosurgeon at University Medical Center at Breckenridge, and was introduced to the technology through the medical director there, Dr. Tom Cabin, who had a relationship with the lab at UT that had this material.
So they've been developing it for years, presumably, at that point?
They had developed it, and they kind of had it identified for a smaller indication. And when I looked at it, I recognized that it's very similar to this material that I mentioned, which is called Seprafilm, and realized that the indication that they thought it might work for could be expanded into a much broader market.
Well, I'm glad you guys are here in Austin. It's always cool to find out that something really neat like that is being developed right here in town.
Well, thank you so much. Appreciate it.
Thank you.
Okay.